Hello, good morning everybody. I am Vishwadeep and I welcome you all on Unacademy Computer Science Channel for unlimited learning. Today we are going to start a very important, very big and very interesting topic of data structure, which is tree. So today we are going to talk about only basic things of the tree. What is the tree, node, root, leaf node, internal node, what are the levels in the tree, height of the tree, and after that we are going to start the next type of tree, which is binary tree, which covers maximum portion of our syllabus. So let's get started for this particular interesting and a very important topic of our GATE syllabus. Before we start, let me introduce myself. My name is Vishwadeep, written the GATE multiple times. This is my final year rank. I am having third year 682 rank. Apart from that, 119 440 ranks under my belt. IISc Bangalore Masters, another Masters from BITS Pilani in Data Science. A rich experience of teaching, as you can see here. And apart from that, these are the courses I am taking on Unacademy's platform. If you want to join us on Unacademy platform, there are multiple ways you can learn from us on Unacademy platform. One of the way is special classes. Go to the Unacademy platform, search my name and follow my profile over there. What you get over there are special classes which are absolutely free for all of you. And another thing is, I have covered lots of theory sessions, practice sessions, and so many good questions I have solved over there. Check it out once and you will be able to get lots of practice questions over there. This is the URL you can use to get all the special classes in the organized manner. So go and check it out. Apart from that, we have started a free test series also for you guys, so that topic to topic, subject to subject, you can prepare the topics, the chapters, the subjects using these test series, and you can assess that how good your preparation is, how well your preparation is going. But still, if you are lacking somewhere, if still you want that you are lacking somewhere, you want better than this, you want more practice, you want more clarity of the topics, you want more grip of the topics, then one option you have is Unacademy Plus. Join Unacademy Plus and you will be able to get 10% discount if you're using the code VDEEP10. Yes, using the 10% discount, you will be able to get Unacademy Plus subscription. But one thing for sure, that on Unacademy Plus, you will be getting those things which you are lacking from the free sources, from the other sources. What exactly you can get on Unacademy Plus? Live classes which are very interactive. I myself felt that the kind of interaction students are having with me on Unacademy's platform, that is amazing. Yes, that is amazing, which is very effective for your better learning. Apart from that, so many doubt solving sessions we are taking, so that if any kind of doubt you have, then you don't have to waste the time in multiple different groups or on multiple different social medias. One channel, one particular problem solving session, and everything will be over from your end. Apart from that, we are giving so many tests, so many practice questions, that students will never ever feel like, yes, we are having lack of practice. All these things come under Unacademy Plus subscription. Remember the code VDEEP10. VDEEP10 code will give you 10% discount plus extra other benefits of my mentorship, my team support, and lots of other things. This particular code is an emotion which will connect you to me and your preparation to my hard work. I will work hard for your preparation, you will work hard for your career, and both together will work hard for your career. So use the code, get the subscription done, and then let's see how best we can do out of your hard work and my hard work. If you are the person who needs a particular personal coach, that personal coach will work for you, your preparation, and that particular fellow will make the planning for your day-to-day study, will give you the preparation strategy, will give you the booster sessions, will give you the test analysis, that where you went wrong, where you can improve, so that in the next test you can get better marks, in the further test you can improve yourself. Plus, if you want study material, all these things come under Iconic subscription. That subscription include all the facilities of Unacademy plus extra personal coach and these facilities. And this particular subscription also you can get in discount if you use the code VDEEP10. If you have any doubt, query, question ki sir how to get the subscription done, why subscription will help in these last 3 months, also will it help for third year, we are in third year or second year, we are preparing for 22 or 23 gate, should we take subscription or not, is it advisable or not? If you have any query, question, doubt, problem, just contact us, we will help you out in the same. Okay, fine. Now if you are ready to start, you know what to do. Are you ready or not? Type down in the comment box and we will start the chapter now. If you are ready, quickly type down in the comment box you are ready, and we will start. Come on people, come on, quickly. If you are ready, type down in the comment box you are ready and we will start now. So what exactly I have brought for you is the all these things done already. Tree chapter. What is a tree chapter? What is the tree? First of all, let's define tree. Data structure. So tree is a non-linear data structure, right? It is hierarchical data structure, and that particular data structure consists nodes which are connected by edges. Now you will ask, sir, what is the difference between tree and graph data structure? Sir, difference between tree and graph data structure is very simple. Key tree is hierarchical structure, and if n number of nodes are there in the tree, then number of edges will be n minus 1. So if n nodes are there, then n minus 1 edges will be there in the tree. That is the basic ट्री डेफिनेशन. क्या आप इस चीज से सहमत हैं? आर यू एग्री विद दिस वेरी बेसिक थिंग? नाउ लेट्स गो एंड लेट्स ट्राई टू अंडरस्टैंड व्हाट इज अ ट्री. सो आई हैव ब्रॉट अ पर्टिकुलर ट्री डायग्राम here for you. Here is the tree 2 and it's this some kind of diagram I have brought for you. Now we need to understand few terms in the tree. What is root, child, parent and something. First of all, the tree data structure will always start from a very specific node, and that particular node is called as root. तो ट्री जो डेटा स्ट्रक्चर है वो स्टार्ट होता है एक बहुत ही स्पेसिफिक एक नोड से जिसे हम कहते हैं रूट. सो दिस इज रूट. You can see that this particular root is already in the red color if you are able to differentiate it. That is the tree data structure. Now listen. What is the root? Already I told you, root is the starting, the very first node of the tree. That is the root. जहां से आपका tree start होता है, from where the tree starts. Next is child. I can say that 7,5 are children of 2. Can I say that? क्या 5 और 7 2 के बच्चे हैं? जी हां, बच्चे हैं. Right. Now, how many children 7 is having? 3 children, 2, 10 and 6. One child of 5, 9. 6 is having 2 children, 5 and 11. 9 is having one child, 4. So you understand what is the children? Okay, fine. If you are understanding that 7 and 5 are children of 2, then what is 2 for 7 and 5? अगर 7 और 5 2 के बच्चे हैं तो 2 क्या है 7 और 5 का? जे की श्रॉफ. अरे तू मेरा बच्चा है, राइट? ऐसे ही डायलॉग है कुछ. Okay, so 7 and 5 are children of 2, then 2 is parent of 7 and 5. 2 is parent of 7 and 5. Right? Similarly, is there any parent of 2, 10 and 6? Yes, 7. Is there any parent of 9? Yes, 5. Is there any parent of 5 and 11? These 6. Is there any parent of 4? Yes, 9. Is there any parent of root? No. Root will not have any parent. Root will not have any parent. Very simple things, बहुत आसान आसान सी चीजें हैं, but आपको याद रखना जरूरी है. Why? Just because for your exams these will be very very effective if you remember these small things very very quickly. Next thing is siblings. If 7 and 5 are children of 2, these 7 and 5 nodes are what of each other? भाई बहन है एक दूसरे के, brother sister. Yes, we will write in the technical term siblings. So 7 comma 5 are sibling of each other, right? Correct or not? Siblings of each other. So I am asking a very simple question. This 6 and this particular 9 also sibling of each other. Can you confirm? 6 and 9 are sibling of each other? No. My answer will be no, and your answer should also be no. Why? Just because sibling means having common parent. Sibling means having same parent, common parent. See, 7 and 5 are having same parent too. That's why 7 and 5 are sibling. I can say 2, this one, 10 and 6, these three are sibling just because having common parent 7, but 9 is having different parent 5. मतलब अगर आपकी रेगुलर लाइफ की हायरार्की देखी जाए, एक रिलेशनशिप हायरार्की देखी जाए, then 6 and 9 are siblings of each other? No, but these are cousins of each other, and cousins are not called as siblings in the tree data structure. है ना, होता है ना, दादाजी के 2 बेटे और उनके बच्चे. सो ये सिबलिंग रियल सिबलिंग नहीं है, cousins हैं, but cousins are not allowed to be called as what? Siblings in the tree data structure. Okay, so tree data structure, siblings are those only nodes which are having same parent. Remember this point, याद रखिएगा, ठीक है. Now let's call as subtree. So subtree means what? Starting from any node till the last level, entire tree is subtree. Like this way. Okay, मैं बताता हूं. Like this way. This particular subtree. How can I call it out as what subtree? Subtree which is starting from 7 as root. Subtree. This is the subtree of my original tree. So this green dotted line is enclosing what? A subtree starting from 7 as root. समझ में आ रहा है आप लोग को? बहुत आसान है यार. इट्स वेरी वेरी सिंपल, बट आई वांट यू टू रिमेंबर ऑल दीज स्मॉल पॉइंट्स. नाउ देयर आर 2 टाइप्स ऑफ नोड. वन इज इंटरनल नोड, वन इज एक्सटर्नल नोड. एक्सटर्नल नोड इज कॉल्ड एज लीफ नोड ऑल्सो. व्हाट इट इज कॉल्ड एज? लीफ नोड ऑल्सो. So what is this external node? External node is that node which does not have any child. Node with 0 child. The node with 0 child. Can you identify in this particular tree what are the nodes which are having 0 child? Means the leaf nodes. This one leaf node, yes. This one leaf node, yes. 10 is leaf node, yes. 11 is leaf node, yes. 4 is leaf node, yes. This 9 is leaf node, no. 2 is leaf node, no. 7, this one 5, no. 6, no. Okay, let me do one thing. Let me just change this particular key as 15 instead of 5. Let me make it as 15 so that this 5 and this 15 can be different. This 2, and let me make this as 12 so that these two can be different. It is 12, it is 2. अब मैं लिखूंगा आपके सामने कौन कौन सी नोड्स जो हैं वो लीफ नोड हैं. लेट्स राइट इट डाउन. ओके, ग्रेट. Now. Okay, so node with 0 child, 12, 10, 15, 11 and 4. These are the leaf nodes. If these are the leaf nodes, what is internal node? Internal node is having reverse definition. Reverse definition means the node with at least 1 child. What is the definition? Node with at least 1 child. If a node is having at least 1 child, अगर एक भी child है किसी node का तो वो internal node. So what are the internal nodes in my example? This one. What are the internal nodes for this particular example? 2 is internal node, yes. 7 is internal node, yes. 5 is internal node, yes. 6 is internal node, yes. 9 is internal node. So 2, 7, 5, 6 and 9, these are the internal nodes just because these are having children. Right or wrong? So I guess in real life, we all are the leaf nodes. Right? Right? I don't know if you understand the jokes or not, but I know you understand the memes. And this was not a meme. It was a little bit intelligent jokes. Okay, fine. Now, fine. Now, somewhere at some booklets, at some kind of tutorials, you might find that root is not called as internal or external node, but in my entire revision, in actual ones, you will always call the root as the internal or external based on its children. If root is not having any child, means it's a leaf node. If root is having child, then it's an internal node. So we will count internal node or external node as root also, or root also as internal or external based on it is having the children or not. क्या समझ में आ रहा है आप लोगों को? Are you guys understanding? If you guys understanding, keep confirming the things that you guys are understanding. Now I will ask a simple question. And then you need to tell me that this particular question is correct, okay, or not, true or false. You need to type down and you need to be very, very quick. Question is very simple. Can we have a node in tree which can be internal node and leaf node both? Quickly, true or false? True or false? Your answer should be true or false. Quickly. I want answer quickly. Can we have a one node in the tree, and that particular node we can say this is the internal node also and this is external node also? Can we have like that? No. Answer is false. No, we cannot have. We cannot have a particular tree in that a node is external also and the same node is internal also. Why? Just because the definition itself is contradictory to each other. The definition says the node which is having children is internal node, not having children is leaf node. Now I cannot have a node which can have child and which cannot have child together. Single node cannot have the both quality, right or wrong? No, not at all. हमारे पास एक कोई नोड ऐसी नहीं हो सकती जिसका लीफ नोड भी है और इंटरनल नोड भी है, पॉसिबल ही नहीं है. So if you are saying a node is leaf node, means it's not having child. If it is not having child, then definitely it cannot be internal node. If I am saying there is an internal node, that particular internal node is having child. If it is having child, then it cannot be leaf node. Simple. Another question. Question number 2. This was number 1. Now question number 2 I am asking. Again, you need to be very, very quick. For this one. Can we have a node which is neither leaf nor internal node? Neither leaf nor internal node means a node which is not a leaf node, in fact which is not a internal node also. Can we have that? Yes or no? Quickly answer. I need the answer, buddy. I need the answer, and my answer is no. I cannot have. If there is a node in the tree, that node should be either leaf node or internal node, nothing else possibility. Third type की category ही नहीं है. There is no any category of third type. So that node should be either a leaf node or an internal node. No any other possibility. And from here we will be having one specific simple observation, and that simple observation will help us solving lots of questions with the tricks. I am saying tricks. When I say tricks, means I will give you the concepts and then after that I will give you the trick ki how conceptually that trick is working. So I'll not only give you the definitions or tricks or something, I'll give you the conceptual understanding of the tricks also. Now see, what is the trick? If total number of nodes in this tree 1 2 3 4 5 6 7 8 9 10 number of nodes we have, then among those 10 number of nodes, if some x number of nodes are leaf node, then 10 minus x number of nodes should be internal nodes. Means कहने का मतलब ये है, the meaning of saying is total number of nodes is equal to total internal nodes plus total external nodes. That should be a simple understanding you should have. If among tree of some 15 nodes, if I am saying that 10 number of nodes are internal nodes, or let's say 10 number of nodes are leaf node, if 10 number of nodes are leaf node, then how many internal nodes will be having? 5. 10 external node, then 5 internal node, total 15 nodes. Can I say that? So I am writing that particular understanding here for your future references, and this we will use so many times to solve so many questions. Okay, I am writing a formula, total number of nodes is equal to total number of leaf nodes plus total number of internal nodes. क्या आप सहमत हैं इस चीज से? N is total number of nodes in tree. Capital L is total number of leaf nodes in the tree. And capital I is total number of internal nodes in the tree. Question is, can we say subtree of considering 6 as root node? See, the thing is, any subtree is possible. There is a subtree starting from 12 as root. There is a subtree starting from 10 as a root. There is a subtree starting from 6 as a root. There is a subtree starting from 15 as a root. There is a subtree starting from 11 as a root. Any node you can pick off the tree and you can say there is a subtree starting from that node as a root. But for my entire tree, I'm not taking subtree. For my entire tree, the root is 2. Right? Okay, got it. This particular definition, whatever statement I have written in this particular box, क्या ये क्लियर है आप लोगों को? इसको एक डब्बे में पैक कर दिया मैंने. अब ये जो डब्बा है ना, ये दिवाली वाला सोन पापड़ी का डब्बा नहीं है कि खुलेगा ही नहीं, कभी इधर उधर से ट्रांसफर होता रहेगा. इसको खोलना है. We will open this particular box when we will use this particular for the question solving. Of course, tomorrow or maybe day after tomorrow or regularly, we will be using almost every day of our tree chapter. We'll use this particular simple understanding. If you guys are clear about this, we will go further. चलें आगे बढ़े यार. तुम लोग बात करोगे तो मजा आएगा तो तुम लोग को सीखने मिलेगा. Now, the regular tree which I am talking about, this is a general tree. What is this? It's a general tree. There is no any restriction on this particular tree construction. There is no any constraint, no any restriction I have put on this particular tree. आप देख सकते हैं, there is no any restriction. Nothing I told कि you should have 2 children maximum, or you should have children like that, or this number of nodes should be arranged like this. Nothing, no any restriction. It's a general regular tree. Now, if suppose we want to write some algorithm, some kind of problem solving on this regular general tree, how exactly we will represent this tree? How exactly we will store that particular tree in the computer system? And for that we have a parenthesis representation. Now here your concentration is needed. You know why? Just because I have brought some 2-3 questions based on this parenthesis representation. So if you will concentrate on one representation, how I will explain, the remaining things you can easily solve. So this is the same tree which I have brought for you. Parenthesis representation. Parenthesis representation is used to actually store this tree in our computer system so that we can run our algorithms on that representation. See, this diagram I cannot give directly to my C language or my Java language or any programming language, right? For programming language, I should have some kind of representation. That is gonna be what? First type of representation is this parenthesis representation. How exactly I am going to represent this tree in parenthesis representation? The syntax should be like this. I'll be writing first the root of the tree, and after that, in the parenthesis, it's all children from left to right. You remember all the children from left side to right side in the parenthesis separated by comma. Separated by comma. As many as children we have. Now, note that I am writing here the point. Okay. So, note that it is possible that these children, child 1, child 2, child 3, all, or maybe some of them, or maybe one of them, or maybe all of them, maybe having some more children. So how we will represent those subtrees? You take child 1 as root like this way, and nested representation of that parenthesis will give you what? Will give you entire tree representation. So note that these children may be further nested. तो ऐसा हो सकता है कि ये जो चिल्ड्रन है उनके भी चिल्ड्रन हो. अच्छा, ये ट्री को कैसे रिप्रेजेंट करेंगे मैं बता देता हूं. आई विल टेल यू, आई विल एक्सप्लेन यू हाउ टू रिप्रेजेंट दिस पर्टिकुलर ट्री. नाउ यू इंटरेक्ट विद मी सो दैट यू कैन अंडरस्टैंड एग्जैक्टली कि व्हाट आई एम डूइंग. फर्स्ट ऑफ ऑल, रूट इज व्हाट शुड आई राइट? व्हाट? 2. In the parenthesis, I will be writing all the children of 2. All the children of 2 separated by comma. So I can write 7, 5. But just because 7 is also further having children, 5 is also having further children, I'll be writing these little bit far. Like this. Now 7 is having children. Yes, 7 is having children. So what I will write? All the children of 7 in the parenthesis separated by comma. So what are the children of 7? 7 children are 2, 10 and 6. Now 10 is not having any child, 2 is not having child, no, but 6 is having children. Yes, so all the children of 6 in the parenthesis after 6 separated by comma, 5, 11. Now 5 is having children. Yes, 5 is having children. What are the children of 5? 5 का child है single child 9. And 9 is also having child. Yes, 4, single child 4. This is my representation. Are you clear about this representation? Yes or no? Quickly tell me. Quickly tell me if you are clear about this or not. If you are clear, then I will give you question to construct the tree using such kind of parenthesis. If you are clear, jaldi se type karo. Are you clear or not? Are you clear or not? All the members who have joined little late to us, please like the session. Like kar do yaar session ko. Okay, and solve this question for me. This is the tree given, represented in parenthesis representation. You need to construct the tree for this. Amazing, Nishu. Amazing. Construct the tree for this. What is the first node? A. So A is the root. Now A is having child B, fine, comma C, fine, C parenthesis open close, then D. So 3 children of A. Now C is having 2 children, E and F. And D is having 3 children, G, H or K. That is the tree for this one. Are you guys clear about this? Are you guys clear about this? Yes or no? Are you guys clear about this? If yes, then see, another question I have brought for you. You can practice by your own on your self copy. I will be giving you the tree here, and you can confirm that your answer is correct or not. This is another tree for you. quickly solve, quickly solve it by your own. Draw the tree. When I will draw the tree, you need to confirm that that particular tree is having correct answer. You, whatever you drawn, that is having correct answer or not. So first of all, A is root. Fine, इतना तो सब बना लेंगे. After that, child C के child हैं B and F. Done. Then A's child D and A's child E. E's children X, Y, Y's child P, Q, and this particular Z is the child of E. So this will be the tree. This will be the tree. Okay, clear. Is that clear? Now listen, there can be a question which is very common question. How can we say that this will be the child, single child, if any node is there? If any node is having single child, then this particular child will be in the left or right. There is no any left or right concept in the general tree. In the general tree, there is no any concept of left or right child. There is the just one concept, which is what? This is the children of this node, or this is the child of this node. That's it. There is no any concept of left or right child in the general tree. The left child, right child concept, left subtree, right subtree concept comes in the binary tree. So there is no any restriction right now on this particular tree. That's why there is no any constraint that this is the left and this is the right or something. That's a general tree. Simple, very simple. आगे बढ़े एक और क्वेश्चन लेके आया हूं. One more question I have brought for you. You need to draw the tree. Okay, this is another question, little bit bigger, little bit tougher, but you can solve it. I know that you can solve it. Yes, you guys are intelligent enough to do that. I know that. I am having belief on you. I am having some kind of belief on you. Just solve it. करो. A, root. Then child B, fine, comma C, fine. C का child E, E का child M and N. Then C का child E, E का child MN, and after that comma means this particular subtree M and N were E's child, and this G is sibling of C. Then G is also having two children, X and Y. Fine. Now next is H. H should also be the child of C only, right? And after that C is having child E, G, H. C is having child MN, G is having child XY, H is having child P, Q, and R. And that's how another parenthesis comes, means C's children are over. Now next is D of A child. A's child is D. D is having three children, I, J, and K. Let's see if you got the same tree by yourself or not. क्या आपको same tree मिला या नहीं मिला? One thing which you need to remember in all these trees, the general standard for parenthesis representation is you need to have the construction. You need to construct the tree in such a way that if first child of E is given M and after that N, then all these should be drawn from left to right. The direction should be left to right. For each child, there is no any confirmation that this is the leftmost only, this is the rightmost only, this is that. So you need to draw from left to right. The sequence should always be correct. You cannot jumble that, sir. M and N we can write in reverse order. No. P, Q, R you can write in any order. No. You should write P as the leftmost, then next is Q, then next is R. That must be preserved. Sequence of the children for each node from left to right. That is the simple constraint of the parenthesis representation. Other than that, there is no any constraint on tree. Tree पे कोई constraint नहीं है, सिर्फ left to right आपको child को manage करना है. That's it, that's it, that's it. Got the same tree, got it. Nice, amazing. Fine. चलिए अब बात करते हैं levels in the tree. What are the levels in the tree? So remember, root is called as on level number 0. Which 0? Which level? Level number 0. Root is known to be on level number 0. Remember that, that's a standard. Remember that root is at level number 0 and all the children of root are known to be on level number 1, and then these nodes, children of these two nodes, all the children of these two nodes will be known as on level number 2, and this will be on level number 3. So this way you can have the levels in the tree. Root at level number 0, then its children at level number 1, children's children will be on level number 2, and their children will be on level number 3, and so on. That is the levels in the tree. Very simple concept. Ji haan, very simple concept. And from here we have another thing which is called as depth. Depth. And what is the depth? Depth is nothing but it is associated term. I am writing first what is the depth. Associated term with a node. Associated term with a node. So whenever somebody will be telling you ki what is the depth, then they will be telling you that depth of this particular node or depth of this particular node or depth of this particular node is what. So what is the depth? Depth of any node is nothing but its level number. Its level number. On which particular level that node is present, that is its depth. That is its depth. Now see if I am asking you what is the depth of node 7. What is the depth of node 7? Okay, I'll tell you, I'll give you the tree. Look at this. This is the tree. What is the depth of node 7? क्या आप बता सकते हैं डेप्थ क्या है नोड 7 की? Yes, depth is its level number which is 1. Depth of node 7 is 1. Is that clear? Is that clear? Is that clear? What is the depth in the previous example of the node 4? Can you tell me what is the depth of the node 4? Node with key value 4 is here. What is the depth? Its level number which is क्या है? आलसी मत बनो, टाइप करो यार, टाइप करो, मजा आएगा. Right? So depth is nothing but it's an associated term of the node and which is nothing but its level number. What is the level number of that particular node? That is the depth of that particular node. Is that clear? Is that clear? Is that clear? Is that clear? Then another definition we have which is called as height of a tree. Now remember what is the little difference, a small difference between height and depth is the depth is associated term with a node. एक single node के लिए आपको depth मिलेगी and height is the associated term with a tree. Associated term with a tree. So whenever somebody will ask you that height of what? So height of a tree, that fellow will ask you. Not a height of a node or something. No, never. Associated term with tree. So you can calculate the height of a tree or subtree, but you will not calculate कि in this particular tree, can you tell me what is the height of 6? No, never. That is the wrong terminology. वो गलत हो जाएगा terms के मामले में. अब देखिए height की जो definition है, वो दो अलग-अलग definition है. There are two definitions. There are two definitions of the height, and those two definitions can give two different answers for this particular tree's height. And what those two definitions are, I will tell you in all the possible manner, and after that I will give you that how or what kind of terminology you will use or what kind of standards you will use so that you can solve the questions correctly in the GATE exam. Okay, so don't worry about that. Everything I will tell you, you need to just understand and acknowledge कि you are understanding or not. तो अभी acknowledge करो if you are understanding, yes, no, whatever, and then based on that I will tell you what is the height of a tree. Okay, so first thing, what is the height of a tree? In first definition, some people says कि height of a tree is maximum level number. So what is the maximum level number in this particular tree? Suppose level number starting from 0. So this is 0, this is 1, this is 2, and this is 3. So some people says कि this particular tree is having height h is equal to 3. Some people are saying maximum level number is the height of the tree. So based on this particular example, previous example, height of this particular tree with definition number 1 will be 3. But some people says in some other definition, they say कि maximum level number plus 1 will be the height. So maximum level number if 3, then plus 1 will be the height, h is equal to 4. These are the two definitions. Based on these two definitions, you are going to calculate your further questions. Whatever the questions which will be having height into consideration. Now, definition number 1, giving this tree's height is equal to 3, maximum level number. Definition number 2, saying that height is maximum level number plus 1. Now, these two definitions which I have shown here, these two definitions can be given in some other terms also. कुछ अलग तरीका हो सकता है. There are other ways also to give the same definition. Means maximum level number will give you the height of the tree. That can be said, that can be represented in some other way also. What is the other way? This is the other way. Height of the tree with single node is 0. अगर आपके पास tree में, if you have single node tree, suppose this is the node which you are having and this is only the tree, what is the maximum level number? Maximum level number is 0. Then you can say that height of this particular tree is 0. So single node height 0. Same definition, same height, yes, but the way of representation is different. कहने का तरीका बदल दिया. Single node height 0. And here single node level is what? Single node level is 0. Then 0 plus 1 will be the height. Single node height is 1. Single node height is 1. H of tree with single node is 1. Another way, just कहने का तरीका अलग है. So all such kind of definitions, possible definitions I have brought for you. I have brought for you all such possible definitions. You just listen, you just understand, you just map these definitions to different statements and you will be able to understand कि what type of definition is given in the question. Is that clear? क्या इतना क्लियर है? जल्दी से बता दो यार, जल्दी से बता दो. मुझे बड़ा मजा आ रहा है आप लोग को पढ़ाने में, just because you guys are understanding quite amazingly. It's very basic terms, very basic, very starting topic of the chapter, but I know you guys are very interesting already, very enthusiastic to learn this particular chapter. So if you are done with this, number 3 definition. If I am saying that single node के साथ height 0 है, if I will remove this tree also or this node also, I'll be having the tree empty tree. If I'll be having empty tree, I have reduced the level by 1. What will be the level if the tree is empty tree? -1. So another definition is exactly same. The height of the tree with empty tree, height of empty tree is -1. And right side, if single node height is 1, single node height is 1, then empty tree height 1 से कम कर दो 0. क्या बात है, crystal clear, क्या बात है, amazing. So these two statements are already, this is defining this one, this is defining this one, this is defining this one, this is defining this one. Now if single node height 0, maximum level number we can say, then this definition number 1 can be represented as like this way also, number of edges in the path from root to the farthest leaf node. जो सबसे दूर की लीफ नोड है, सबसे दूर की लीफ नोड, the farthest leaf node means the leaf node which is present on the last level. Suppose these are the leaf nodes, maybe 5 or 11 or 4. What is the path from root to this? 2 to 5 to 9 to 4. How many number of edges we have? 2 to 5 1 edge, 5 to 9 2 edge, 9 to 4 3 edges. 3 edges are there. Number of edges in the path from root to the farthest leaf node. Maybe this one, 1 2 3 this one, or maybe 1 2 3 this one. Farthest leaf nodes are having 3 edges in the path from root to the leaf node. That is why you can write the definition like that way. Farthest leaf node. So path from root to the farthest leaf node, how many number of edges are there? In right side, we will calculate or we will count number of nodes. Number of nodes in the path from root to the farthest leaf node. 1, 2, 3 and 4. That's why height of this particular tree becomes 4 in the right side definition. Got it, got it, got it. If you got it, then other way to write the edges is the distance. Distance, you can see here. Root to root. What is the distance from 2 to 2? 0. From here 1. From here 2. From here 3. So distance from one node to another node, if it is directly child of that node, then 1. Then 1. Then 1. Like this you can calculate. So instead of writing edges, you can count the distance also. These are the 4 definitions you should understand properly. Now, बात आती है कि which definition is standard one. Which definition is standard one? There is no any standard. There is no any standard in the GATE data structure questions. So, sir, फिर कौन सी definition use करेंगे? You will use the definition which will be given in the question. Sir, every time they will give you the definition. Yes, every time you will have any question which requires height to be calculated of a tree, then in every such question they will be giving you a particular definition of the height, how you are calculating the height of a tree. So you don't have to worry ki which definition to use, but yes, you need to worry about that ki because of this definition what should be the height of the tree. Itna to kar sakte ho. Can you do that? Yes, you can do that. I believe you. You also believe yourself. You can do that. There is no any standard. There is no any standard. It's very simple. It's very simple that if you are going to solve any question based on the height, you will be having a particular question given. In that question, you will be given a small definition that what type of definition you are going to use to calculate the height. Now, there is another term here called as degree. Usually, in this particular tree, degree is equal to number of child of a node. Degree of a node is nothing but number of children of a node. How many number of children that particular node can have. Fine. Now listen, I will give you a tree and based on that we will try to calculate the degree. Fine. Okay, so can you tell me in this particular question, in this particular given tree, what is the degree of A? How many children A is having? 3. So degree of A is 3. Then if I am asking you what is the degree of node G? Is there any child of G? This is G. No. If I am asking you what is the degree of node D, which is equal to 2, 2 children it is having, and if I am asking you what is the degree of node F, answer should be 1. Right? Right or wrong? Right or wrong? Right or wrong? Yes or no? Yes or no? Clear, clear, everybody clear, 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 clear or not clear? If you guys are clear, then I can have a claim here. I can have a claim here and you need to give me the proof that that particular claim is true or not. I am writing degree of a leaf node is always 0. Degree of a leaf node is 0 always. Is that particular claim true or not? Yes, true. Just because we calculate degree as what? Degree usually we call as number of children of a node. Number of children are 0 means it's a leaf node, or it's a leaf node means number of children 0 means degree 0. Simple सी बात है यार, definition ही तो लिखी है, definition ही तो है. True, 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 true. Yes, true. Everybody clear about this? Now I want to ask you a simple question. Based on definition number 1, we are using the definition number 1. Definition number 1 means height with single node 0 or maximum level number is the height. Can you tell me what is the height of these drawn trees? What is the height of this particular tree? Can you calculate? What is the height of this particular tree? Can you do that? Jaldi se batao. If height of the tree is equal to 0 with single node, then height of the tree for this particular node 0, 1 and 2. 2, 2, 2, 2, 2, 0, 1 and 2. Only 3 levels you are having, low level 0, level 1, level 2. 2, 2, 2 for this one. If single node height 0 I am taking, definition number 1 I am taking, how many maximum level you can have? 0, 1 and 2. Maximum level number is 2 number. Level number, maximum level number is 2. Okay. Now for this one, tell me. For this one, what should be the answer? Single node. So it is 0, 1, 2 and 3. So h of this particular tree is equal to 3. Right? Right or wrong? Jaldi bata do re yaar. Is that clear? Clear? Okay. For this one, what is the height? H of tree is equal to 0 with single node. Then for this particular question, what is the height of the tree? 0, 1, 2, 3. 3. Yes or no? Chaliye, means you guys are clear about these heights and level and depth and all, right? Okay, fine. चलिए, तो आज का सेशन यही खत्म होता है. Only basic things I wanted to clarify. Tomorrow onwards we are having the binary tree, and in that I want everybody to be present. Why? Just because if you understand the basic 2 lectures of binary tree, then you will be able to definitely get 2 marks in the GATE exam. 100% sure, just because definitely 1 mark will be coming from this binary tree. So tomorrow we are going to have some binary tree basics. Maybe if we will be having some more time, then we will start tree traversal. If not, then maybe the day after we will start the tree traversal. Traversal is very easy topic, but I will give you another short trick how to calculate traversal and how to get the correct answer within just seconds. I will give you 2-3 types of different methods how to calculate the tree traversals, and in that particular case you will be having really great grip ki how to calculate traversals, and reverse using the traversals how to construct the tree. All these things we are going to do tomorrow, and day after tomorrow. You can't bunk these classes, not at all. Okay, so next 2 lectures are really important for your tree chapter and for your 2 to 4 marks in GATE exam. Very important, just because tree से definitely question आता है और वो बहुत easy होता है. There are very simple questions from the tree, so you cannot bunk those classes. Okay, so we'll meet tomorrow again at 10 a.m. but before that we will meet at 7:15 p.m. also for COA. Okay, so if you want to learn lot if you want to learn, then you need to come live for the classes. COA बाकी की सारी classes चल रही हैं यार. You just check out all the playlists which are there in this particular channel. Go and learn. It's a complete package we have brought for you. And one more thing I want you to tell you again, if you want to go for Unacademy Plus subscription, use the code VDEEP10 and get the subscription done as soon as possible, so that your preparation will always be effective, more efficient, and less time wasting. Please recommend to your friends these particular channels. This is the channel for electrical, mechanical, civil, Telugu language, SSCJ, computer science. This is the channels for computer science. Subscribe it, enable your notifications, share the lectures with all of your friends so that those people also can be benefited. And if you want PYQ sessions, I have already taken PYQ sessions of my two courses, COA and data structure, on special classes. Unacademy special classes पे ले चुका हूँ. आप एक काम कीजिए, you go to this particular URL tiny.cc/vdeep10. On this particular URL, you will be getting a Notion page organized by me. That particular Notion page has a data structure PYQ link. Go and check it out. All the PYQs, previous year gate questions, I have already taken, but I will surely take those PYQ sessions also here also, so that you guys can learn again, once again, in the more effective manner. Okay, thank you so much for joining me here. Happy learning. Have a nice remaining day. We will definitely meet again. Till then, have a nice remaining day.